Hello, students. You must be familiar with these structures while traveling. Am I right? These structures are carrying high voltage transmission lines, which bring electric power to your homes. Isn't it amazing to see the entire city getting light because of these high voltage lines? I'm sure you must be wondering, where is this so much of power generated? Yes, so the objective of the class today is to understand these power generating stations and the transmission of power from the generating station to the consumer. So let's begin where the power is generated. Yes, I'm sure you know this is a hydroelectric power plant whereby the potential energy of water is getting converted finally to electrical energy, or the solar power plant. Well, not only that, there are many other power generating stations. As you can see, man has learned how to convert wind energy, fossil energy, nuclear energy also to electrical energy. But these power generating stations are located at places very far from the cities. And that's the reason this power has to come through the transmission lines to our homes. Well, I can figure out that you have more questions about the power plant, that how much power is generated, what's the voltage, and whether it is alternating or direct. Let's take it up one at a time. Well, this electric power which is generated, as we saw, there were varieties of power plants. It depends upon the type of the power plant, the size of the power plant. But generally, it is generated in megawatts and gigawatts. At what voltage is the electric power generated? Yes, it is 11,000 volts, which can be written as 11 kV. That high. But do you know how much voltage do we get in our homes? You're familiar with how much voltage do you get in this socket? Yes, we get 220 volts. And this makes you wonder now that why is 11,000 volts generated at the power generating stations when we just need 220 volts? Well, we'll understand this by the simple formula, power is voltage into current, right? P is equal to V into I. But for a given power, if your voltage is more, the current is small. Higher the voltage, lower will be the current. Let's understand this by a very simple example. For example, you have a number 100, fixed number 100, which is equal to 25 by 4, 25 into 4, or it can also be 50 into 2, or it can also be 100 into 1, 1000 into 0.1. So you can go on increasing the voltage and thereby the current goes on decreasing for a fixed power, right? So that's the reason at the generating station, we have increased the voltage to 11,000 volts so that the current is less. Well, then a question again arises in the mind that if higher the voltage, lower is the current, and if our purpose is to lower the current, then why only at 11,000 kilovolts? Why not higher? Well, then there are certain technical issues that insulation problems or insulation difficulties happen when we take up higher voltage. So, well, now 11,000 kilovolts has been generated, the power is generated, and now it's coming towards you through the transmission lines. But definitely you will wonder, Is it transmitted at this high voltage? I'm sorry, it's not yes, it's no. It is further stepped up. 11,000 is much less. It's further stepped up. So if the voltage is stepped up, current will further step down, right? So let's have a quick recap. At power station, 11,000. Then from the power station, the power first goes to a grid substation where it is stepped up. There are certain transformers which which will step up, means increase the voltage from 11,000 to 132 kilovolts. And it is this much amount of voltage is there in this high voltage transmission lines, 132 kilovolts. At that very high voltage, it's being transmitted towards your homes. Also, let's understand. So at that high voltage, obviously the current is also being passed through the transmission lines. And if current is passed, heat is generated in the lines. We know heat is I square RT. That is, heat is directly proportional to the square of the current, directly proportional to the resistance of the wire, as well as time. But now let's focus. If the current is less, heat will also be less. So there will be less loss of energy due to heat. We don't want our power, we don't want our energy to be wasted while it is traveling in the transmission lines, right? So in the transmission lines, power is transmitted at a very high voltage so that there is lower current, and because the current is low, the heat loss also will be less or will be minimum, right? But then it does not come to our homes at 132 kilovolts. So just like we have a step-up transformer, there are step-down transformers. And they bring it down to 33 kilovolts. And then they are transmitted to the factories at 33 kilovolts. Certain factories do require this high voltage. Or sometimes the step-down transformers will bring it down to 11 kilovolts and further step down to 220 volts. That's how it comes to our homes. So if we see it in a diagrammatic manner, at the power station, 11 kilovolts, stepped up at the grid station to 132 kilovolts, and then further step down periodically. The first step down to 33, which will be sent to heavy industries. The next step down is at the other substation to 11 kilovolts, which will send power to the light industries, and further step down to the city consumers at 220 volts. So these are the 3 step downs stations, right? But now, is this voltage generated AC or DC? It's AC, which has a frequency of 50 hertz. Now, what does that mean? 50 hertz means the polarity at the two ends is changing. Polarity is changing 100 times a second. 50 times 50 hertz means 50 times at one terminal and 50 times at the other terminal. So a total of 100 times a second. That's why the frequency is 50 hertz, 50 per second. Okay. Definitely, why not direct current? Direct current can also bring the same amount of power. But the only reason for this is that the step up and step down is not possible for DC voltage, right? Now at homes, we are getting 220 volts, but then at what frequency are we getting it? That's the same as 50 hertz at our homes. Well, let's do a small recap now. At what voltage and frequency is the power generated at the power stations? All right, that's 11 kilovolts and 50 hertz. We have been asked the voltage as well as the frequency. And at homes, what is the voltage and frequency? 220 volts and 50 hertz. So isn't it amazing that this electric power generated at the station, power generating station, it's been transmitted all the way through so much distance and it comes to your homes. So isn't it our moral responsibility to save electricity? Yes, so don't waste it. Thank you so much. We shall catch up again for the next topic very soon.